All right, so let's start with this. The aim of this video is to show how to solve a data science problem using an agentic method, what I will call is agentic data science framework that I'm building. And our problem is this predicting stellar classes from Kaggle. It is a playground project, not too complex, but very beautiful. I like it. So let's look at the problem first, and then let me show you my framework then, and then let me show you how I put that into the play and what did the results look and how I approached through the process and what I have at the end. So the problem is this. We have some small set of feature sets. We are looking at the balanced accuracy, and we're predicting if these objects in the sky are galaxies, stars, or quasars. And I made a submission, actually made a two submission, improved it after doing an ensemble. We're going to look at it. It's not that important. I like it, but the main thing here is the approach. So let's look at the, let's go this. The entire framework, it's not that too complex. So I have this cage files, Antigravity, and Codex. Let's ignore them. I'm following this agents protocol, which I like to use, and I'm improving. And similarly with everything, I have my agents.md, I have my conventions.md, I have my devs, readme, and I have my systems.md. Okay, and those things I'm building, and I like those, and I'm improving those. What I like to focus more is the workspaces, because that agents protocol is already everyone's using, and we're building our versions of it, and I'm building my version of it. What I'm doing here is not too different as well, but my touch, and it is within this framework. I have this folder called workspaces, and for each project, each thing that I'm working on, I'm creating a new workspace, and for that I have a workspace template. I just duplicate this and then just rename it and work it towards there. Each template has these three structures and one project.md. The project.md is very crucial. It defines the goal, the success criteria, and the constraints and the important nodes and data. And this guides the agent and also me, but mostly for the agent, also for my memory. But yeah, and then I have this raw processing and outputs folders, and each of these have the same structures, but they differ in the way what they mean and in the way that agents are allowed to use. So raw is agents are only able to read. They read from this and then they process it and have processed data here or generated outputs. They cannot touch raws at all, but I can do. They can do whatever they want in processing, and they can generate outputs. They can read outputs. They can regenerate outputs, the new ones, but they cannot rewrite or change anything that's in the output folder. That's my approach here. So for the playground project too, I did that. But before that, I had some more unstructured approach, going back and forth with the agents or ChatGPT, etc. Sometimes, or just like this manual notebook I have here. And after that, I had some things. So the first is EDA for any this type of work, right? So I look at my data. I look at what are the columns look like. So it's a synthetic data, and everything looks perfect, more perfect than it should be in the real life. So it is in the real life, or maybe not. I don't know. I didn't check this type of data yet. So maybe NASA, if they provide it, there won't be any missing data anyway. But that's not the point. Let's focus. So I generated this pair plots, look at the data, I see, oh, there are these three different clusters here, and I have three classes. So maybe that is something to look at. And then I see some of these follow normal distributions, some left or right, and oh, I see there's a group of features here that all seems to be linearly correlated with each other. So I'll look at the days, etc. So I am noting these things when I'm looking at it. So, and then I look at the correlations. Oh, again, I see these things. And this box of highly linearly correlated features. And I look at this and then I need to learn though. So for someone who knows what these means, it is very obvious. These are wavelength frequencies for these colors, and it is obviously there's going to be a huge correlation there. But yeah, this is the diving deeper into the data. And there's this redshift, and once I learned what it is, it really made sense on why it has high correlation with this. So let's not dive too much into that, but I'm very inclined towards that and talking about it. I really liked it. So I did some checks with the ANOVA, and then I looked at the different classes distribution against redshift. So for the stars, it seemed a lot more, but in one area, and yeah, this already shows very clear separation with the redshift too. But yeah, this is what I looked and what questioned. And while looking at these things, and I have some um, takeaways from these, I had some next steps notes for these. These are very rough notes. I look at these, look at that, or maybe this, or maybe just copy paste from something to just some response from AI to like look into it later on. And some takeaways I took, and these are raw notes. So after having these raw notes, what I did is that I feed this workspace entirely in this playground project folder into Codex. And it could be anything else, it doesn't have to be Codex. But I opened the Codex and I gave it a goal. And my goal was that, hey, let's build a baseline submission together step by step, and based on what I have this here. And what I requested was this. So it's not a definitive answer, and each time I do these things they differ a lot, and this is just one way. You should not do exactly as I do, because I want to next time as like this as well, and I'm a growing expert in here. So just try to see some points that you may like or not, and just see what it is. So what I did it was this. So I asked it to, okay, I have these notes, and I have these points that I'm curious about, and I have this goal. Consider all of my takeaways and consider what I wanted to do as the next steps. Let's go step by step, and let's go build some notebooks. And I want you to build one notebook at a time towards building a submission. And after generating each notebook should also generate some outputs, results, and for you to check. And after each notebook run, I'll check, you'll check, we'll talk, and we move to the next step. So one by one, we build these notebooks, and at the level 6, I started to build the submission. And then at the 8, I compared the things and I prepared one submission that I wanted. And then I did an ensemble of that. So what I did here was that, so the first thing was, let's look at some feature importances. That was important here. So let's build a tree and look at feature importance. And it was very supportive of Redshift and these color bands as well. And it was useful data. So, okay. But then I had this one concern about, not concern, but curiosity about this thing I saw. So I noticed that these color bands have high correlation with them. And okay, that's expected. But I also see some of them seem skewed, and some of them seems more normal distributed, like this U and the Z. I don't know if that makes anything, but I was curious and I asked, hey, can I use one of these to make use, or maybe I don't even need to use 5 of them and I can make the same prediction with 1 of them. Maybe that's the parent band. Or maybe I can figure out new things from there. So that was one idea and that I was curious about. And my questions led to this. And we did this parent testing thing. So we checked the U class that I was suspicious about. The by using all the other ones separately or only of those, or like adding with the redshift as well. So it's not a complete ablation study of everything for every aspect for controlling every parameter, but that is what we did. Um, so that ablation study with everything is the future next step of mine. So this is the baseline, remember. I'm just trying to first, let's have baseline, and then from there I'm going to improve it gradually. So this showed some things, but it was not very meaningful. It was not leading to very significant differences that I was curious to chase for. And then what I did is, okay, let's continue checking, but that is a good idea. Let's keep that in mind. But I wasn't entirely sure as well. So we're just continuing, right? So I'm not jumping into any conclusions. I'm building. So then I wanted to do PCA, and I requested to do a PCA, and a PCA was useful. It so some PCAs were showing more signals than not, but at the end I ended up not using it because of building a tree model, and we don't have a lot of features too. So if you look at our own data, we actually have very few sets of data anyway. So I mean the features. So and comparing that with using a tree model, which which has the potential to find those correlations and by itself. And anyway, I didn't use PCA here because of the reasons I already outlined, and it makes sense. And I'm just trying to go over it very quickly because it's already very fast and long. So, and then the next step was I built a logistic regression because I was very curious about it. Actually, I initially wanted to do logistic regression to choose some PCAs, but that was not what I ended up doing. What I ended up doing was just using all the features to see if the L1 penalty was going to zero out some of the features, but it didn't. So I continued. I continued to, okay, let's keep all the features there. And of course, these are going back and forth and learning together and building towards it. And I still have some points that I'm discovering, and maybe some of these points here are very obvious to people with some domain experts, etc. So you need to be questioning all the time. So and look it up. So and I wanted to use this discussion part too. It helped me a lot see some other problems. It's like using Google as well. So learning from outside world. So not just focusing on one thing. So agent here is an assistance. Is there when I ask things. It's there for me to get to some of the things quicker than I would in normal times. So the next thing was building engineering features. So PCA was to, and the L1 steps was to, hey, maybe let's filter these features to 1 or 2 things, but okay, that didn't go very well. So then let's expand our features. Let's have more features instead. So in here we did some color features, and the color features were based on the differences between the colors. So subsequent neighbor wavelengths, their differences are the new color features, just to show some maybe new signal. So this came from the model. I wasn't aware of this. Maybe I needed to do some more research and maybe talk to some experts, and maybe my teammate would help me with this, and I would help more with the engineering side or maybe the project side. But the agent here helps me to try that thing that I wasn't even aware of, maybe was going to spend hours of, and I did this and I tested it and it works and it's good, and I can do a research on it and continue very faster. And then we did add in this residual features, which was again using this parent band U. We simply did prediction on each child bands, the other bands that this is kind of testing the Notebook 2 idea. And we predicted child bands and take the residuals from those and use those residuals as features in our new data set. And now we have color features from neighboring wavelengths, and we have residual features from parent band. And now we have this new feature set. And then what happened is another feature importance and test and comparisons to see what to do, what to use, what to not use. And here we did the select K best things, and then we did use some of the features, and then we did some hyperparameter tuning with testing some different steps, but it was not too extensive. So what I can say is that so we tested smaller step size, we started more depth, also estimator size, but it wasn't that too many of different outputs. So I did have 3 different models and just few different variations, because what I wanted was to build a baseline. So in here with the light GBM, I already provided some baseline with this one. It was good and it was useful. But then what I wanted was, okay, that's good, but let's have some more depth to it. Okay, if we have this light GBM model with all the features are used, it's providing good, useful result. And then what I can do is we can build an ensemble, and we can do an autofold validation training and see that results of those as well. So we did that, and that actually showed some good results as well. So my plan was I thought it that, hey, okay, I want to build an ensemble, but what I want is this. I wanted to build, so not just light GBM, I wanted to include also cat boost and XGBoost, and which ones I should use. So we tested different parameters of light GBM, XGBoost, and cat boost, and 3 out of fold validation test training for each of them. And then the model tried different blend versions of these 3. And blending 50-50 light GBM and XGBoost, and the same thing with the cat boost, and all of them with 0.33. So actually, maybe I said something wrong 1 minute ago, but the point is 3 different models, and then their combination of their blends with equals and 2 parts and 3 parts. But yeah, that's not the main purpose anyway. The main part is how to approach the problem. But yes, that's how I built this ensemble model, and then I submitted it. So based on understanding of this helps to build things, but also it is very possible to lose track of what you're actually building. So in each step, I constantly ask questions, and even from my current explanation, you can see that there are things here that I am not 100% confident about, but there are things that I'm 100% confident about. But there's also this awareness that, okay, hey, I'm not 100% confident about that thing, and I want to question that thing. So based on those, I also created this next steps, and the next steps is just create an ablation studies of filtering out each of these components and then building this um, greater model. And then that part will give me the real understanding of what each component adds and what each of these uh, adds value significantly, or what parts of these are actually noise that I don't want and filter out. But in my current workflow, they're just included because I didn't check that granular, and I just found it that okay, using some set of features is not good compared to using all of them, because I just use all of them and I didn't create for example that parent band test for the other feature I was curious about. So you see, I did this baseline, I did an improvement, and I had these questions, so I can test this very quickly. Normally, even this one notebook could have caused me a day, or maybe just questioning one of these can take me a day, or maybe I needed to wait an answer from one person on Stack Overflow or my teammate, or do a research, and I still need to do those, but it helps immensely. All of these I did in, I wouldn't say more than 4 hours. Yes, and it's beautiful. I learned a lot, and it is it is one good of a thing. And this is how I did. In the future, I'll shape this and I'll see how it goes, and I hope it gives some idea. So make sure what you understand what you're building. It may be okay for playground project, but this is not how you work in business, right? So this is a learning project. In business, you need to understand every single point and every single thing in every single step while you're submitting it. So here, doing that will take me more time, and but that's the point of it. It makes you test things that maybe it wouldn't be possible to test in 4 hours of time and learn about it. And yeah, since I started to circle on the same topic, let's close this and say goodbye to this video.